Welcome back to this 5-part series on strengthening of reinforced concrete beams with CFRP jacketing using ABAQUS. In first video, I talked about creating parts. If you have missed first video, the link is somewhere around here. In this second video, I will talk about how can we create material properties and how do we assign these properties to the parts created in first part. The series is divided into 5 parts. In first part, I will talk about creating geometry. Second is about material properties and sections. Third is about assembling those parts. Fourth is about meshing, loading, boundary conditions, contact interactions, and job submission. Finally, fifth and last part is about viewing the results. This is a problem that I'm going to solve today. The details are given in this book. These are the material properties. Hey friends, if you're new here, I am Dr. Jawed Qureshi, a senior lecturer at a London university. On this channel, we explore technical and human skills to help us lead more productive, happy, and examine life. The second part is about defining materials and creating cross-sections and assigning those cross-sections to the parts that we created in first part. The next is property module. Go to property, and here I will create properties for all materials. So let us create S250 steel and S500 steel. The main bar is going to be S500. These are the dimensions which I'm going to use here. So double click on materials. Say S500, click on mechanical elastic, and here use Young's modulus as 200K, and then it's 0.3, and density is 7.8 e raised minus 9. It's kg per millimeter cube. And then I will define plasticity parameters. 400 and plastic strain is 0. 500 and plastic strain, the ultimate strain that I'm going to use for this one is 0.25. Normally for these bars, mild steel bars, we use up to 0.2 to 0.22, but here in the book they have used 0.25. Click done, and then I will define S250. They call it G250, but I call it S250. And here again, Young's modulus given is 185,000, but they've used here, normally for steel it is 200 gigapascal or 210 gigapascal, but here the given modulus is 185,000, so I'm going to use 185,000. And yield is 200, ultimate is 250. So let's put these properties. Another model S250, and elastic I will say 185,000, Poisson's ratio 0.3, and density is again 7.8 e raised minus 9. Plasticity parameters are 200, I have plastic strain 0, and 250, I have plastic strain at 0.25, and then click OK. And then I will define concrete C30, and here I will use concrete damage plasticity, and I will use this C30 for both concrete jacketing, and I will use C30 for concrete beam as well. Here, the only difference in this book is that for jacketing, the elastic modulus is a little bit different, but again, I'm going to use the same C30 concrete. So density will be 2.4 e raised minus 9, and Young's modulus 25190, Poisson's ratio 0.1. And I'm going to define these plasticity parameters, which are the default parameters recommended in ABAQUS documentation guide. Double click on materials, say C30. And here I will use elastic modulus and Poisson's ratio 25190, 0.15. And then I will use density, although density is not required here because I'm going to use the static model, but if you wanted to use the same model as a dynamic model and apply slow loading, then density comes into play. 2.4 e raised minus 9. Then I will go to plasticity, and I will go to concrete damage plasticity. And here dilation angle, I will use these parameters. Dilation angle 35, and 1.67, 0.66, and 0. 1.66. And then yield stress, compressive behavior, yield stress is 24. This is where concrete starts to yield, and after that, the maximum is 30 Newton per millimeter square. Tensile stress is 2.46. So I will click on compressive behavior here. It is 24 and 0. The compressive behavior will have sub options as well, but here in this book, compression damage and tensile damage is not defined. Ideally, if you wanted to have crushing of concrete and cracking of concrete model, then you have to include these two options. In that way, you will be able to see where concrete is cracking, especially on the tension side. This is a subject which is for another probably complete lecture or a video, but just to make sure that you know that these options are there, and it will work really properly if you put these properties. And again, I will go to tensile behavior. Yield stress is 2.46 and cracking strain is 0. If you give complete stress strain curve in compression, and in tension, if you give the damage parameters over here, then in that way you'll be able to properly see where concrete is cracking and where concrete is crushing. But here in this book, these values are not given. The authors have a companion research paper which is published recently, 2022. We'll put a link to that paper as well. Click OK. Concrete material has been defined. Next, I will define CFRP rods, where Young's modulus is 165,000, Poisson's ratio 0.3, and yield stress is taken as 1860, and strain is 0. And this has got its density as well. The properties of anchor bolts are given as well, and epoxy is given, but it is something which is not used explicitly in this model. And I will use mass density of 1.55 e raised 9, and here Young's modulus given as 165,000. I will double click on here. I will write CFRP and mechanical elastic 165,000. Poisson's ratio is 0.3 and density is 1.55 e raised minus 9. Density is quite lighter as compared to concrete, and plasticity parameters I will use 1860. Plastic strain is going to be 0. In that way, CFRP has been defined. Then I will define the section. As diameter of main bar is 12 millimeter, the cross-sectional area is not 123, it is 113. It is a typo mistake in the book, so make sure you correct this mistake. And again, the area here is 113. So I will use a truss section, and the top bar has diameter of 8 millimeter, and its area is not going to be 55, it will be 50. So make those changes. Links have diameter of 8 millimeter as well, and steel will be S250 for links. So I will use a truss section for main bar and top bar, and links for 3 of them I will use a truss section. So let's see how we can use it. So double click on section. First say top bar section. I'll use beam, truss, and here material is S50. Cross-sectional area is 50. Click done, and I will use bottom bar section, bot bar sec. Again, it's going to be a truss. Material is S500, so 113 for the bottom bar. And then I will use link section, links section. And here, the only difference is that I'm going to use the material as S250. The area remains the same as top bar. It will be 50 millimeters square, and click done. Link section has been created. And then I have to create section for beam and section for concrete jacketing and section for CFRP bar. For concrete beam and concrete jacketing, I'm going to use the same C30 concrete material. So then double click, I will say RC beam section, and it will be solid section, homogeneous, and the material is going to be C30. Click OK. I will use C jacketing section. Again, this will be solid, homogeneous, and material will be C30. The only thing remaining is CFRP. So CFRP rods, it will be 28.3, not 113. So here it's not 113. because the diameter is 6 millimeter, so it will lead to 28.3 millimeter square. So let's create CFRP rod section. So it has a diameter of 6 millimeter, cross-sectional area cannot be 123, it is 28.3. So go to CFRP rod section. So go to beam and truss, and here material is CFRP and 28.3. Click done. In that way, sections are created. Now I will assign these sections to all the parts. So starting from bottom bar, double click on section, choose the bar, click done, choose the section as bottom bar section, click OK, and then concrete jacketing, click on concrete jacketing, double click on section, choose the section and choose C jacketing section, click done, and then I have CFRP bar, double click on CFRP bar, click done, and choose the CFRP rod section. And then I have link section, double click on links, choose the section and click link section, click done. Then I have RC beam, double click on section assignment, choose the entire section and choose concrete beam. And then I have top bar finally, double click on section and simply choose the section and click on top bar section. In that way, I have assigned all sections. We are not done yet. In next part, I will be talking about assembling parts. Click at the end screen to come on over. If you have missed first video, check it out at this side of end screen.